Hello friends, welcome back to session 5 of DevOps. So in this session we are going to cover the CIDR, which is called the classless interdomain routing, which is very important topic in the DevOps and specifically related with the infrastructure. Okay, so whenever you go for the working with the Docker containers or the Kubernetes or any of the other infrastructure solutions, okay, or maybe in the cloud, okay, so this CIDR will come at multiple places because this is the notation that we use to assign the IP addresses. Okay, so some of the basic understanding that we have got in the previous session as well on the CIDR. Okay, so in this session I am going to explain in bit detail, okay, with the examples, okay, how we calculate the CIDRs and how we divide the CIDR into the different subnets, or basically when we create a different subnet based on a CIDR, so how we define the different CIDR range for creating the subnets. Okay, and we have some online tools as well which you can utilize to quickly create the number of subnets in a particular CIDR or to calculate the number of IP addresses. That is also possible. Okay, but in a nutshell, the basic concept of CIDR should be clear if you really would like to have a proficient DevOps expert. Right. So before we explain the CIDR, okay, the first we have to understand the traditional IP addressing scheme. Okay, the traditional IPv4 addressing scheme. Okay, so let me explain you first the traditional IP address schemes and some different classes. Okay, how we define the IP addresses and how we define the classes of IP addresses, and then we'll jump into the CIDR once it is clear to you. Right. So basically, how we define an IP address, we all know that the IP address consists of the 4 octets in the form of x dot x dot x dot x. Right. For example, there would be IP address 192.168.1.0. Right. So every number in the IP address is called the octet. This is called the octet. So how many octets we have in a particular IP addresses? We have total 4 octets in an IP address. Right. 1, 2, 3 and 4, and each octet is of 8 bits. That means each octet, we have a 4 octet, so each octet has 8 bits, right? So that means in an IP address how many bits we have? 8 cross 4, 32, right? 32 bits. So this is the very first thing that you understand. Each IP address has 4 octets, okay, and each octet is of 8 bit. So total we have 32 bits in an IP address. This is one of the core concepts where we calculated or understand the a particular IP address contain the 32 bits. Okay. Now we have a different class of IP addresses. Okay. Based on that, we do the reservation of IP addresses in a particular network. Right. For example, if we have a particular network for our organization, okay, and we are expecting certain number of IP addresses, or you can say the servers or machines in our network, okay, then we reserve the IP addresses for our network. Okay, and the number of IP addresses that we reserve for our network, it depend on the classes of the network. So we have a 5 class A, class B, class C, D, and class E. Okay, so these two are not really required for you to understand. Okay, because these are for some testing purpose, or you can say the experimental purpose, and class E for the multicast address. So we have to deal mostly with the class A, B and C IP addresses. Okay, so now what does it mean, class A, B and C? So if we talk about class A, okay, class A IP address is also referred as /8. Okay, now why /8? We know that each octet is of 8 bit, right? So we have 4 octets. So if I am saying class A refer as /8, so this /8 represent the network ID. Now what is network ID? So in a particular network we have multiple machines, right? and we have multiple network across the world, not a single network, right? And you can connect any of the network. For example, you have some friend or relative in the USA, you are sitting in India, right? And you can directly contact with that person who is sitting in different country, or you can chat of the over the different tools as well, chatting tools, or you can contact directly to the person who is sitting in different countries. Like how it is possible? This is with the help of internet, public network, right? But when this kind of a connection created, when one computer in the network identify the other computer in the network which may be in the different network, so this is your separate network and this is your separate network, right? So that means in each and every network, to identify a PC, we have two parts in an IP address. One is the network part, which is called a network ID, and second is the host ID or the server ID, right? So this is the two part of an IP address, right? So the first part, to contact any of the IP addresses over the internet, okay, your internet look for the network ID, and then once it is reached to the network ID, then it look for the particular host which is there inside a particular network. So now what we will understand here, in each and every IP addresses we have the network ID and then host ID. So when we say /8 or the class A, that means one octet or the first octet is reserved for the network ID. So that means if we have an IP address like x.x.x.x, so the first octet is reserved for the network ID, and these three are available for the host. Okay, so in a nutshell, 8 bits are available for the network ID and 24 bits are available for the host for assigning the different kind of a host which we have in our network, right? And for class A, this particular address, or you can say the first octet range, is from 0 to 127. Okay, that means if you are seeing an IP address something like 121.6.5.0, by seeing this IP address you can quickly identify this IP address belong to class A. How? The first octet value is 121, right? And this is fall in the 0 to 127. That means this IP address belong to class A, right? So two things we have learned here: how we can identify a particular IP address belong to class A or some different class. If the first octet value is between 0 to 127, this is a class A IP address, and the rest 3 bits are available for the host computers. Okay, so I will show you that particular calculation as well. Okay, how to identify the number of hosts. Now similarly, if I go to class B, so class B is also referred as /16. Now what is /16? That means in an IP address x.x.x.x, the first octet and the second octet, these two octets are reserved for the network, and rest of the two octets are available for the host. Okay, and for class B, the value of the octet is vary from 128 to 191. So if you see here, the class A was ended at 127, right? And now class B started from 128 and it can go 191. Okay, so now if you are seeing some IP addresses, something like 188.20.6.1, so now you can quickly identify this IP belong to class B, because the first octet value is 188, which fall between 128 to 191, right? So this belong to class B. Now come to class C. Class C IP address. This also referred as /24. Now why 24? If we have an IP address x.x.x.x, so first 3 octets are reserved for the network ID, and the last octet is available for the host. Okay, so now in class C, the value of the first octet is from 192 till 223. So now if you are seeing some IP address like 198.4.6.1, so you can quickly identify this belong to the class C. Why class C? Because the first octet is 198, which fall between 192 to 223, and this is a class C range, right? So now if we try to look for the total number of hosts that is possible in a particular IP addresses, okay, then the number of hosts in class A will be very high. Why? Because 3 octets are reserved for the host, right? And if I go to class B, only 2 octets are reserved for the host. So the number of hosts in class B network will be less than class A. And if we go to class C, where only 1 octet is available for the host, the number of IP addresses in class C will be less, very less in comparison with the class B and class A. Right. So this is the funda of your IP address, octet, number of bits, right? And then class A, class B, and class C, and how to identify a particular IP address belong to class A or class B or class C, which is based on the first octet. And the range of the octet we have seen for class A, it's 0 to 127. For class B, it is 128 to 191. For class C, it is 192 to 223. Right. So this is the first part. Now let us come to the second part. Let me open a new board. Now, in IP address, we know that now every IP address has 4 octets, and each octet is of 8 bit, and total we have 32 bits in IP address. Correct. Now the maximum value of each octet can go up to 255 only. 255. That means whatever the IP address we have, suppose 192.168.1.2, similarly we have some more IPs. Okay, it can't go beyond 255.255.255.255. That means each octet maximum value is 255. Why 255? Is very simple, because in each octet we have 8 bits, 1 2 3 4 5 6 7 8 8 bits, right? So simple calculation, 2 raised to the power 8, this will come to 256, then minus 1, which will come to 55. So this 255 will be the maximum value of an octet. Now why minus 1? Because it starts from 0. 0 से 255. Right? This is the next thing you have to understand. The maximum value of an each and every octet can go 255, and what is the calculation of that? How we calculate? Correct. Now let me move forward, but before that let me quickly erase all these things. So now let us quickly see how many IP addresses are possible in class A, class B, and class C IP addresses. Okay, and what are the drawback of that? So that CIDR came in picture. So now if I talk about, sorry, let me take the pencil. If I talk about the class A IP addresses, where x dot x dot x dot x, and what we have learned, the first bit is available for the network ID, and the rest 3 is available for the host ID. Right? So that means these 3 octets are available for the network ID. So total how many bits are available for the network ID? Total 24. Right? 4, 8, 8, and 8. Total 24 bits are available for the host ID, and these 8 bits are available for the only for the network. So 24 bits are available for the host ID. So calculation is very straightforward. 2 raised to the power of 24. If you are not from mathematical background, then 2 raised to the power of 24 means multiply 2 24 times. It can go up to 24 times, and this will come to 16 million. So that means in class A, we have 16 million IP addresses are possible. So for your network, if you have reserved the class A IP address scheme, then you can configure the 16 million IP addresses in your network. Now if you come to class B, again x dot x dot x dot x, and what we have learned about class B, the first 2 octets are reserved for the network, and rest 2 are available for the host. So how many bits are available for the host? Total 16. So 2 raised to the power 16, that means multiply to 16 times. right? And this will come to 65,536. So that means if you are taking class B network, you can have the 65,536 IP addresses in your network. Now come to class C. Again x dot x dot x dot x. So in class C, the first 3 octets are reserved for the network ID. Only 1 octet is available for the host. So total 8 bits. So that means 2 raised to the power of 8, which will come to 256. So that means your total number of IP addresses that is possible in class C is 256 IP addresses. Now let us try to understand the drawback of this one, of this particular classes IP addresses. Now suppose that you have a requirement where you need 350 IP addresses for your network. 350, right? So which class you are going to take? You cannot go for class C because it allow only 256 IP addresses, right? Your requirement is 350. So now on top of class C, if you are not able to use class C, you can go with the class B only, right? And class B allows 65,536 IP addresses. Your requirement is only 350, right? Now you can minus this 350 from 65,536, and now you can think that how many IP addresses you are wasting. Your requirement is 350, but class C allow only 256, which is very less, or very less, bit less than your requirement. So there is no option, you have to go for class B, and now you are wasting a lot of IP addresses here. Even not 350, you have a requirement of 257 IP addresses in your network, which is only one more than class C. In this case as well, you have to go for class B. You do not have any choice. Now suppose in same way, if your network need 65,000 IP addresses, so class B allow only 65,536. Your requirement is 66,000, which is bit more than class B. Then you have no choice. You have to go for the class A networking IP address scheme. And now it allows 16 million IP addresses, and your requirement is only 66,000. You can minus this 66,000, 16 million, and you can think that how many IP addresses you are wasting here, right? There is a hard dependency to select either A, class B, or class C IP addresses, and this is the way how we are wasting a lot of IP address scheme, and that's why this CIDR came in picture. Now what is CIDR? Let me quickly open a new whiteboard and let me explain you. So with the help of CIDR, we eliminate the waste of IP addresses. Eliminate the wastage of IP addresses. And what is the wastage of IP addresses? Just we have seen in class A, class B, and class C. So what happened in CIDR? In CIDR, we can specify only the number of IP addresses that we are expecting in our network. So for example, if I'm saying that I need the 257 IP addresses in my network, so I can define a CIDR which will be in the form of x dot x dot x dot x slash forward slash and then x. There will be a number after the forward slash. So this number after forward slash, it denote the network ID. Network ID, or you can see the number of bits available for the network. I will explain you what does it mean. Right. So what we understand here, the format of the CIDR, x dot x dot x dot x and forward slash and then x. Right. For example, let me take an IP address CIDR 192.168.1.0 slash 28. This is the CIDR I have given to you. Right. Now, if I need to calculate how many IP addresses are possible in this particular CIDR, okay, it's very straightforward. There is only one formula. What we have learned so far, how many bits are available in an IP address? Total we have 32 bits, right? 8 bits per octet, 32 bits. And this 28 bit slash 28, this 28 is denoting the number of bits available for the network ID. So you just need to minus this number from 32. and see what is the coming. It is coming as 4. So total number of IP addresses that is possible in this CIDR is 2 raised to the power of 4. That means multiply to 4 times. 2 into 2 into 2 into 2. So this will come 16. So in this CIDR, I can have 16 IP addresses. Right? So now if my requirement is only 16 IP addresses, then why should I go for the class C, which allow the 256 IP addresses? And if I am going to use 16, and if I go for class C, then still I am wasting 240 IP addresses, right? Because my requirement is only 16 and class C allow the 256 IP addresses, right? So by this way, with the help of CIDR, we eliminate the wastage of resources, and with the help of CIDR, we can arrange or we can allocate only the IP addresses that we required, right? So now what we learn here, the format of CIDR, it is 192.168.1.0, which is x.x.x.x / and then there again a number, and this number represent the number of bits that is available for your network. And to calculate the total number of IP addresses in a particular CIDR, just take this last number which is after the format, which is denoting the number of bits for your network, minus it from the 32. Whatever the value is coming, make it 2 raised to the power of this value. Okay, and this will be the total number of IP addresses possible in a CIDR. This is a very straightforward calculation, how to know the total number of IP addresses available in a particular CIDR. Right, now hope it is clear to you. So let me move forward and let me show you how we can work when we do the subnetting of a CIDR. Okay, so basically what happens when you are in a network, for example, I am in a network, and for that particular network I have reserved the IP address 192.168.1.0/28. This is the CIDR I have given to my network. This is my network, and I am expecting total 60 machines here or 60 IP addresses here. So that's why I have given this particular CIDR, right? So it is 28. So 32 minus 28 equal to 4. 2 raised to the power of 4 equal to 16 IP addresses, right? So this is the CIDR I have given. Now, what we have learned in the networking sessions, we can divide a network into the subnetwork, subnetting. That means we can do the partition of our network, which is called the subnet. And why we do the partition? For segregating the resources. For example, I have a development environment, testing environment, quality environment, and the production environment. Okay, and I want to restrict the traffic between all these environments, so that I have created different subnet. This is subnet 1, this is subnet 2, this is subnet 3, and this is subnet 4. So when we divide a particular network in the subnet, then for each subnet we have to define a CIDR for each and every subnet. Okay, and this CIDR of the each subnet define the number of IP addresses in a particular subnet, like this is here, right? So this is the parent CIDR, which is defining the total number of IP addresses inside the complete network. And now because I am going to create a subnet, so because this is a partition of my main network, so whatever the CIDR that I have to define for my subnet, it should be derived from this particular range. Now what is the meaning of range? What we know, this particular CIDR contains the 60 IP addresses, right? And what are those IP addresses? What are those 16 IP addresses? We should know about that one, right? Because the CIDR that we will going to assign to subnet, it will be only from those 16 IP addresses, right? Not outside this one, because this is a part of my main network. So how we know what all are the 16 IP addresses that is fall in this particular CIDR range? Let me tell you, it's very simple. Let me write the IP address again, 192.168.0. Let me take 1.0 / 28, right? So total IP address is possible 16. So the very first IP address, which is going to start from the same, which is 192.168.1.0. This is the first IP address. Second, 192.168.1.1. This is second. Second, 192.168.1.2. 2. This is the third. 192.168.1.3. This is fourth. And by this way, it will move, right? And because it contains the 16 IP addresses and starting from 0, so the last IP address will be 192.168.1.15, right? This will be the last. So this is the first IP address and this is the last. Why it is last? Because the IP address is starting from 0, so last one will go till 15. Correct? So 1.0, 1.1, 1.2, 1.3 and similarly it can go up to 1.15. So these are the 16 IP addresses that is possible in this CIDR range. This is the way how we calculate the CIDR range, or you can say the IP addresses that is possible in a particular CIDR. Right? Now, how to define this CIDR for the subnet? Let me show you. Let me write it again. 192.168.1.0/28, and this contains the 60 IP addresses. This is my network, and this is a CIDR of my network. Inside that, I have 4 subnet, and to each subnet, I need to define a CIDR. Right? Now, as I said, these CIDR will derive from the main CIDR. Right? And what are the IPs possible in this range? We have calculated in the some time back. It's very straightforward, right? Now, suppose that I want that 4 IP addresses in each and every CIDR. So that means the CIDR that I have to derive, it has to be in a format which will allow 4 IP addresses in each subnet. Right? So what would be that? Simple. 192.168.1.0, okay, and then /30. Why 30? Because 32 minus 30 equal to 2, 2 raised to the power 2 equal to 4. So this /30 will give you the 4 IP addresses. So this will be supposed for the first subnet. Now come to second. So now because the 4 IP addresses are reserved for this CIDR, so that means 1.0, 1.1, 1.2 and 1.3 are reserved here. So this is going to start from 1.4. So 192.168.1.4 / again 30, because I need 4 IP addresses. Now what are the 4 IP addresses? We will start from 1.4, 1.5, 1.6 and 1.7. Right? So now it will start from 1.8, and similarly it go for /30, 1.8, 1.9, 1.10, 1.11. So this is going to start from 1.12. That means 192.168.1.12/30. Right? So by this way, what we have done, we have splitted this single network CIDR into the 4 sub CIDRs. And to splitting that main CIDR into the sub CIDRs for the subnet, we should first know the calculation, how we know that the IP addresses that is possible in a particular CIDR range, and then how we split it into the different sub CIDR range. This is very important in terms of the infrastructure, specifically in the DevOps. Okay, now let me give you a very quick way to identify that as well. There are multiple tools are available, because I have given you a very simple IP addresses for the calculation, but in a real production scenarios, it could be very complex. The range of CIDR, the number of IP addresses may be very large, and in that case, you may feel it very difficult, okay, to calculate the number of IP addresses. So in that case, you should have some handy tools with you which can help you to trace quickly. So for that, we have these 2 URLs. This is the first URL, and let me show you what exactly it is. You can access it. Okay, so it can give you the total number of the number of IP addresses that you have you in your CIDR range. For example, if I give the same 192 and then 168, then 1.0, and let me give it 28. Okay, so how many IP addresses are possible, and what all are the IPs? These are the IPs starting from 1.0 to 1.15. I would like to calculate the CIDRs as well of the subnets. Okay, that means you would like to split a particular main CIDR into the multiple CIDRs to assign it to the subnets. Okay, so you can go to this particular URL. Okay, and then I will show you, okay, how to calculate. So here you can specify the IP address. For example, I have given the 1.0, okay, and 28 is the mask bits, and update. Okay, so now here you can see this is the total number of IP addresses are possible in this adder is 14. Okay, so why it is 14? Because we have calculated the 16 number of IP addresses. It is showing 14 that you can assign to host, because what happened in insider, the first IP and the last IP is reserved for the network and the broadcast. Okay, this is again an important term that you have to understand, that in insider the first IP and last IP you cannot assign to the host, because that is for the network, okay, and for the broadcast. That's why it is showing the total number of 14s you can assign to the host. Okay, if you do the calculation, 32 minus 28, it will come to 16. Now you can divide it in the different subnets. You can click on this divide option. Okay, now here you have two subnet, each of 6 hosts. That means you can assign these subnet address to your different subnets, these address. Okay, if you want 6 hosts, you can further divide this, okay, into the other further subnets. These will be the CIDR for your different subnets. Similarly, there are multiple tools are available on the internet. You can just search for that and you will get the multiple online URLs. Okay, for the calculation of the CIDRs, and then calculations of the CIDR for the subnets. Okay, so this is a way how we define the CIDR. What is the purpose of CIDR? How we calculate the number of IP addresses? How we divide that into the multiple sub CIDRs for the subnetting. Okay, and the default IP addresses, drawbacks, and the benefit of CIDR in comparison with that.